Now, this is the exercise that we dealt with in closing. And then Bianca got positive infinity, Levan got positive infinity, and then Marvin said, the limit doesn't exist. Then I request the main reason I requested Levan and Bianca to not be away from us today, even if they had other commitments, was to explain in simple terms how they got to this positive infinity. Levan, please just share with us how you got to it.
X plus 2 divided by, lim x approaches 1 is x plus 2 over open bracket x minus 1 close bracket squared. And then my denominator is having squared, meaning I have 2 brackets. So I said lim x approach 1, x plus 2, open bracket x minus, divide, open bracket x minus 1, close bracket x, and then open bracket x minus 1, close bracket. And then after that, I said limit x approach 1, and then I said x plus 2 divided by x minus 1 multiply by 1 over x minus 1. And then I said lim x approach 1, x plus 2 over x minus 1, and then multiply by lim x approach 1, 1 over x minus 1. And then after that, I said where I see x, I substitute 1. So there in equation x plus 2 over x minus 1, I substitute 1 where I see x. So I got 1 over 0, which is positive infinity. And then where 1 over x minus 1, I substitute 1 where I see x. And it gives me 1 over 0, which is positive infinity. So I said positive multiplied by positive is positive, which gives me positive infinity. I'm finished, sir.
Okay. Please ask them whether they did follow what you just said or not.
Okay, guys, did you follow what I've just said? Or should I send it on the chat, the photo?
High level, your steps were very similar to the ones that I did, except that I think I got lost in the last bit where it's 1 over 0, and then you guys went with infinity, and I went with not defined.
Oh, okay. So you must know every time when we get here on limit, when we get something divided by 0, it's gonna be, if it's positive, it's gonna be positive infinity. If it's negative, it's gonna be negative infinity. Am I correct, sir?
You are right, Level. I agree with you.
Oh, okay. Thank you, sir.
Bianca is here, Glenn, and Marvin.
While Lev was explaining, the one who asked the question, was it Marvin or who was it?
It was Marvin.
It was Marvin. Okay. Now, let me thank Levo for having explained to Marvin. Marvin, are you okay now? Marvin? All right. Then, Lebo, thank you for that explanation. Then I do agree with what you said. Now, let's continue. Where are we going now? We are now coming here. In this exercise, where did I write? Okay, I wrote here. Let's see now. Here is my request. Okay, not my request, a question. You all understood the way Lebo explained the previous exercise. Now, let me request you to solve example 1.3.10. Please evaluate the limit of x minus 3 over 4 minus, the limit of x minus 3 all over 4 minus x, in the next bracket, x plus 3. Are we all clear? Hello?
Yes, sir.
Okay, thank you. Let's evaluate the limit of x minus 3 all over, open bracket, 4 minus x, open bracket, close bracket, open bracket, x plus 3, close bracket, as x approaches 4. The very same way that we did the previous exercise.
I'm not sure with my answer, but I got positive infinity over 7.
Positive infinity over 7.
Yeah, oh, infinity, positive infinity multiplied by 1 over 7. I'm not sure.
Hang on. You say you got?
Positive infinity multiplied by 1 over 7.
Okay. Then now, when you multiply positive infinity by that positive number, what do we get?
Positive infinity.
That's what we are looking for. No. That's not what we are looking for because we don't know what Bianca found. Bianca,
I got positive infinity if it means that I have to multiply what I've got by 0, then my denominator is going to be 0 and numerator will be a 1.
your final answer, Bianca?
It's positive infinity.
Level, I agree with the positive infinity. Bianca, I agree with the positive infinity. Anyone who disagrees or who doesn't follow how we are getting this positive infinity? Lebanon and Bianca.
Okay.
Lebo and Bianca.
Yes, sir.
All right. The two of us, the three of us agree on the figure that you gave me. Okay.
Okay, sir.
Yes, sir.
But we are not done. Here is my question to you. Here is my question to you. You evaluated this limit when x approaches 4. Is that what you did?
Yes.
And all of you got positive infinity.
Yes. Yes.
Who's talking? Is it?
I don't
Oh,
know.
that's
Yes,
Bianca.
yeah.
Lebo, you just
Yes.
evaluated this function, this expression
Yes,
when
sir.
x approaches 4. 4 as it is, eh?
Yes, sir.
Oh, okay. Now, let's talk. Do you see this expression?
Yes, sir.
Okay. What is it that we observe? What is it that we all observe when we just replace x with a 4?
It's 1/0. No.
Sorry?
When we substitute x to the original formula without solving it, you are saying that
Mhm. That's what
yeah,
I'm saying.
you obtain 1/0.
1/0.
Yes.
That's Lebone.
Yes, sir.
Bianca, what are you saying? Do you agree?
Yes, you obtain 1/0 because that 0, you got it from 0 times 7, which is 0.
Okay. Now, I agree with what you said. Now, by direct substitution, when we substitute x with 4, we end up having 1/0. We all agree on that, ne?
Yes.
Yeah, sir.
Yes, sir.
Hello? How are you? This is what I'm saying. We have got x minus 3 all over 4 minus x, open bracket x plus 3. What I'm saying to you is that when we put in the place of x, when we put 4, we end up having, in the numerator, we end up having 1. In the denominator, we end up having 0. We all agree about that, on that one. Ne?
Agreed.
Yes. Now, this is what I need to say. That's why I said I agree with Bianca, also agree with Lebo. But that is not the way to go. Okay. Remember yesterday, I talked to you about, there is another exercise that I dealt with you. In this case, we have to evaluate this limit when x approaches 4. What we need to do, when we are in that situation, in the situation where we, as a result of direct substitution, we end up having a, what do we call this? Infinity. We then evaluate the given limit from both sides. Meaning, we'll evaluate this limit when x approaches 4 from the left and see what we get, and also evaluate this limit when x approaches 4 from the right. Are we together? Huh.
Yes, yes, sir.
Following,
That
sir.
is what we need to do. We need, because that is a direct observation. We do observe and notice that when we substitute x with 4, we get this function to be undefined and leading us to conclude that it is actually giving us positive infinity. That is not the way to go. The way to go is that we need to evaluate this function. We need to evaluate this limit when x approaches 4 from the left, and also evaluate it when x approaches 4 from the right.
Yes,
Am I
sir.
making sense?
Yes.
Okay. Thank you. Noma Homed. No, Mohammed?
Yes, I'm answered now, but I did something different, but then I understand how you got it, how you got the answer. So,
No, Mohammed, I'm confused now.
no, so I understood how you got the answer. How you got the infinity, positive infinity.
Yes, but what I'm saying, that is not the answer that we are looking for. Because that one is straightforward. When you take x and put it in the place
Yes,
of
sir.
x, we'll end up having positive infinity. We all see that. Ne?
Yes, sir.
Yes. What I'm saying is that what we
Yes.
need to do is to evaluate this limit when x approaches 4 from the left. That is what I'm requesting you to do. Evaluate this limit when x approaches 4 from
Okay,
the
sir.
left. When you are done, then we can start to talk.
Okay, sir. Okay.
Yes.
All right, sir. Thank you.
All right.
Sorry, sir, I got cut off by the network. You asked us to do what?
Is it Bianca?
Yes, it's Bianca.
Bianca, okay. What you said, and then even what Lebo said, ne? Is
Yes,
that
I have
by
it. We need to
you
do
got
it from the left or the right.
what? Let's start by evaluating this limit when x approaches 4 from the left. Let's start there.
Okay.
Before we go to the right-hand side.
Glenn Vuyo's hand is up. He just joined the class. Maybe he needs clarity on something.
Thanks, colleague. Vuyo,
Hello, sir.
how are
I've
you?
just joined the class now. Which limit are we working on?
Do you see example 1.3.10?
Yes, sir.
We are evaluating this limit when x approaches 4 from the left. That is what we are doing.
All right, sir. Thank you.
We are only evaluating the limit of this function when x approaches 4 from the left. Only. Then from there, we'll check our answer before we evaluate the limit when x approaches 4 from the right.
So to clarify, we are doing exercise 1.3.10, right?
Yes, we are only evaluating the limit of this function when x approaches 4 from the left. Only for now. We'll check the answer before we go to the other side. Vuyo, what did you get?
I get positive infinity.
Vusiso, what did you get?
I also got positive infinity, sir.
I agree with both of you. Vuyo, please talk to those others, whether they agree with you or not, before we evaluate the limit when x approaches 4 from the right.
It's Bianca. I do agree.
Hello,
Thanks,
guys.
Bianca.
You agree?
Yes, Vuyo, I agree. It's Bianca.
We are together, Bob.
Okay.
Let's wait for others. Let's hear from others.
This thing of to the left, to the right is confusing me.
Lebo, please talk to Vuyo. If
Yes,
you are
sir.
not satisfied, if you are not satisfied with the explanation that Vuyo will provide, I'll explain more.
Yeah, Mr. Vuyo, you know what?
Yes, ma'am.
Yeah. The problem is, I know how to evaluate limits, but the problem is now when it comes to this thing of the to the left, to the right. So now we are evaluating to the left, right? When x approaches to the left. So can you explain to me how did you do that?
Okay. When they say x approaches 4 from the left, it means that x it's less than 4. When they say x approaches 4 from the right, then it means x is greater than 4.
Yes, I know that one. You can
All right.
continue.
You are, when they say then x approaches 4 from the left, you approach 4 with all the numbers from maybe negative infinity towards 4.
Okay.
Same as when they say x approaches 4 from the right. You approach 4 from infinity to 4.
Okay.
Same as when they say x approaches 4 from the right. You approach 4 from infinity to 4. I don't know if you understand.
Okay, so now on our axis, what are we going to substitute?
Sorry?
Where we see x in that equation, what are we going to substitute?
What I know is that if x approaches a certain number, then you only substitute that number if you are not going to get 0 in the denominator. But if you get 0 in the denominator, you will have to rationalize the limit. You'll have to, yeah. That's all I know.
Was that Vuyo?
Yes, sir.
Thank you, my brother.
Thank you, sir.
Lebo.
Listen, when it approaches 4 to the left, you substitute 4. When you approaches x to the right, you still substitute 4. Am I correct or am I wrong?
You are correct.
Okay, so
But
what
remember, if they are saying it approaches x 4 to the positive to the right, it means that you're going to take points that are greater than 4. Then let's say if they told you to plug in your, draw in your graph, then those points will work, especially if you're drawing your graph.
Yes, so now we are not drawing the graph. So it's still the same.
Yeah, if you're not drawing the graph, whatever x intercept that they gave you, you just plug it into your formula. But then just remember that you need to factor out whatever given function that you have.
Yeah, so meaning now, if Meniere says we're supposed to calculate the limit when it x approaches 4 to the right this time around. So we are going to get the same thing when it approaches 4 to the left. So there's no difference.
Are you sure? Lebo.
To be sure, I'm not.
Lebo.
Yes, sir, I want to be sure. I'm not sure. That's where I don't understand this concept.
Okay. Did you get Vuyo's explanation?
Yes, I did.
Okay.
I know that one because we were talking about it yesterday.
All right. There is nothing. I didn't introduce any concept from yesterday. I'm just continuing with what we spoke about from yesterday. Okay. Let's say for argument's sake, ne? Lebo.
Yes, sir.
In
Yes,
this case, we are saying X is approaching 4 from the left. Okay.
Yes.
Give me any number. I'm trying to simplify it, but Vuyo explained it far much better. So now I'm bringing in numbers, and then I hope I will not confuse you with what I'm going to say. Okay.
Yes. You know the way you explain it right now. You explain it the same way yesterday. So I did give you those numbers yesterday. Ne?
Yes.
So now, the you know, this thing confused me when they say to the left, so I supposed to substitute for the, and then even if to the right I supposed to substitute for the, and then I'm going to get the same answer because it's going to be positive infinity.
Yeah, but most you are not going to get the very same answer after my explanation.
Okay.
Because most it will mean that I didn't explain properly to you.
All right.
Yeah. Now, most I want to explain it to you in terms of numbers. Okay. Remember where we started, ne? By just looking, let's go back to where we started. I said by observation, whether in an assignment or in an exam, when you get this kind of an exercise, ne? By observation, when you see that, okay, these people are saying to me, I must evaluate this limit when X approaches 4. But then by observation, you realize that once you put 4 in the place of X, this expression becomes undefined. Then you know that you need to evaluate this limit when X approaches 4 from the left, and then even when X approaches 4 from the right. Whatever number that X will be approaching it from. Oh, no. Whatever number that you will be given, then that means that you will have to evaluate that limit when X approaches that number from the left and then even from the right. That is the hint, the crucial hint that I can give you to say, if you get this kind of a question, either in an assignment or in an exam, by observation, you see that when we put X in the place of 4, this whole expression will be undefined. We do agree, ne? Level?
Yes,
we agree
sir.
on that?
Yes.
Thank you. Now, the next thing now is to evaluate the limit when X, whether you start when X approaches 4 from the right or from the left, it doesn't matter. So now let's say, as we started, we said no, X is approaching 4 from the left. Now, look at it from this angle. Give me any number on the left-hand side of 4. Level.
Yes, sir. Sorry for that. You said any number far from the left, right? I will say
Give me
negative.
any number which is on the left-hand side of 4.
Yes, I will say -5.
-5, eh?
Yes.
Okay. Now, thank you for that number. When we put that -5 in the place of, let's say, in the next step that we'll have to do from this given exercise is to separate, meaning we'll have the limit of X minus 3/4 minus X and the limit of 1 over x plus 3, both as x approaches 4 from the left. That is what you will have. Ne?
Yes, sir.
Now,
So,
starting with when x with x minus 3 over 4 minus x, you gave me minus 5. Ne?
yes.
Thank you. Let's put that minus 5 in the place of x in the numerator. What do we get?
-8.
Put the minus 5 in the x below, in the denominator. Level.
Yes, sir. Yes, sir. I'm still calculating. I'm sorry. -18.
What?
-18. Yeah,
Your answer will be -18, isn't it?
yes.
Thank you. In the denominator. Okay. That means we have got -18. When you'll tell me whether I'm wrong or right. You said to me, when we put minus 5 in the place of x in the numerator, it will be minus 5 minus 3, which means it will be minus 8, okay, in the numerator. Lebo, are you with me? Something is not making sense to me. Oh. Lebo. Lebo doesn't hear me. Regardless of what Lebo found, if we use, as an example, -5, from x minus 3, 4 minus x, we'll get a negative number. Do we agree? Hello?
Yes, sir.
People?
Yes, sir.
We'll
Yes, sir.
Yes, we do.
We'll get a negative number. Now let's go to the limit of 1 over x plus 3. When we put minus 5 that Lebo gave us in the place of x, we'll end up having a negative number. Do we agree?
Correct.
Now, these are two negative numbers. When you
Yes,
multiply them, when we multiply them, we're going to end up having a positive number. Okay. Do we agree?
Yes.
Regardless of what those numbers are. But now taking into account that when we substituted at the beginning by observation, when we substituted 4 there, this expression gave us infinity, became undefined. So now this concludes that, how should I put it? Then this then holds that our number or our answer is that positive infinity. I don't know the way I'm explaining it, whether it's making sense to you or not.
It does, sir.
Thank you. Is that Bianca? Vuyo,
Yes, sir.
does it, is Melvin here?
I'm here, sir.
Marvin,
Yeah,
is my explanation making sense?
100%, man.
Okay. Now, in less than 2 minutes, or let me say, I'm giving you a maximum of 2 minutes to work out, to evaluate this limit when x approaches 4 from the right.
I got negative infinity, sir.
Who's that?
It's Marvin.
Is it Marvin?
Yes, it is.
Okay, please talk to them. Ask them what is it that they're getting.
Hey, I'm afraid.
Negative infinity.
Yeah. Yes! I'm not wrong. Whew, thank God. I must get something right tonight. Yo, hangek.
Do they agree with you, Marvin?
One is better than zero, sir.
Let's wait for the next person. Then if the second person agrees with you, then we step off this. Level, this is what we said in simple terms, ne? Quickly before you get disconnected. Ne?
Yes, sir.
You gave us that number of -5, okay?
Yes, sir.
When we take that number that you gave us -5 and then we put it in the place of x in the numerator, we get minus what? -8, ne?
Yes, sir.
When we put -5 in the place of x in the denominator, we end up having a what? A positive number, okay?
Okay.
But overall, the number that we get end up being a negative number.
Yes.
Then now let's go to the lim of 1 over x plus 3 as x approaches 4 from the left. You gave us -5, okay?
Yes, sir.
Let's put -5 in the place of x. What do we get? -2. Do we agree?
Yes, sir.
When you multiply these two numbers, what do you get? Level.
Yes, sir. Positive.
Positive. Now, taking into account where we started, remember we said no. When we substitute the value of x, this expression becomes undefined.
Yes, sir.
That clarifies our positive infinity.
Oh, okay. So say you are saying if approaching x to the left, right? And then
From the left.
yes, from the left.
I know English is not our mother tongue.
Yes.
I'm listening, Level.
And then I substituted those numbers. I choose any number. Before I do that, I substituted 4 to the original equation, and then I got 1 over 0, right? And then I know it's infinity that way. And then when I substitute any number from the left that approaches 4, that approaches 4, I got any number, right? I got positive. When I multiply them, I got negative, positive. And then if I go left, I mean right, and then I choose any number. If I choose 2, not 2. If I choose 5, positive 5, I will get a negative number, right? So which means this clarifies that it will be a negative infinity, because from the start I know it's an infinity. So if I substitute x to if limit x approaches 4 from the right, and then I get a negative number, it shows my infinity is negative. Am I correct that way?
That is a strong word. I don't have that word in my vocabulary. In this case, Lebo, we are dealing with two numbers. Is the limit of x minus 3 over 4 minus x as x approaches 4 from the right. From there, if you take any number to the right hand side of 4, you will end up having a negative number. Do we agree?
Yes.
Then when you take the limit of 1 over x plus 3 as x approaches 4 from the right, meaning taking any number to the right-hand side of 4, you will end up having a positive number.
Yes.
Then the product of those two will give you a negative number. Okay.
Yes. Yes.
Regardless of those numbers, taking into account where we started, taking
Yes.
into account that this becomes undefined, then that justifies our negative infinity.
Our positive infinity.
Negative.
Oh, negative, yes, negative infinity. So we say, I see. Yeah, I get it now, sir. Thank you so much. Thank you, sir. Thank you. Because this question was in our test, and I think I got it wrong because I didn't understand it. But now I understand it. Thank you, sir.
Okay, thank you.
Sorry, sir, can I ask something real quick?
Yes.
Not to bring more confusion to this. I'm just trying to kind of like get to the last part of my understanding here. We evaluated for when x is approaching from the left and when x is approaching from the right. When x is approaching from the left, we got a positive infinity, and when x is approaching from the right, we got a negative infinity. So what is the final answer then? Because there's two parts to that answer.
Okay. Good question, which I expected. Now, hopefully, I'll be able to help. This is, as I said, who was talking? Dube. I can only see Dube here. Is it Marvin?
Yes,
oh, Marvin. Yes. Yes, Marvin. Let's move down to see the conclusion. And then there are still Lebo. Please don't panic. I've got many exercises related to this. I've got a number of exercises that I will share with you. Then you will work on them until you become comfortable at handling this kind of exercises. We all agree with this one, on this part from the observation. What am I like?
Yes.
Yes, no? Thank you. Now, look how these people then approach this. Do you see this part? Ah la la. Okay. Do you see? Okay. Do you see this part of the positive infinity?
Yes, we do.
Do you see? Do you see the part of the negative infinity?
Yes.
Therefore, now, how do we conclude? Marvin?
The limit
I said this is checkmate for me.
It's a what?
It's a checkmate. This is where I get stuck now.
No, don't get stuck. Okay, now.
Sir?
Remember, okay. Someone sent us up. Who's that? Please talk.
So I did it differently, sir. I said,
who's talking?
C4x minus 3 over.
Who's talking? Oh, no, Mohammed. Yes, I'm listening.
No, Mohammed, sir.
Yes, thank you. Please go ahead.
Yes, sir. X over 4x. Yes, sir. I said x over 4 minus.
You are breaking. You are breaking. You are breaking, brother. Maybe others can hear you, but I'm struggling to hear you.
Yeah, he's breaking, sir.
Marvin, Marvin.
open bracket, x plus 3. I put that equation apart, like equation number 1. Ish. Yes, sir.
No, Mohammed.
Can you hear me now, sir?
My brother, I'm struggling to hear you.
Struggling to hear. It's okay, please carry on.
Okay, thank you. Now, Marvin.
No, Mohammed, sorry, sir. Can you please just type in his question on the chat?
Yes, please. Then, yeah, please tell Bianca, ask him to type. Then, when he's done, then anybody then can just share with us what he wrote in the chat. Now, Marvin, good question. Now, let me take you back. Back, not here. Back. Let me take you here. Do you see number A? You see this A? Uh-oh.
Can you hear
You see this
me now, sir?
Sorry? Marvin?
Yes, I can see it.
Do you see
Mohammed was asking if we can hear him now.
Can you hear me now?
No, Mohammed. No, Mohammed, type on the chat and I'll read the question for you. Type on the chat.
Okay, Marvin, we need to conclude now on what we were dealing with. Remember, from the observation, we realized that that given function, it is actually undefined from the beginning. So then we can, that is not the way to go, to just conclude by just substituting and saying, okay, this, and this, oh, we cannot just conclude by observation to say, that, as our answer to say, it is undefined. Once we realize that by observation, this is what we do. We calculate the limit from the left, also calculate the limit from the right. Then, if these two limits from the left and the right are equal, meaning we are getting the very same answer, therefore, that means that the limit of f of x does exist when x approaches that number. So that means, now let me go.
Okay.
Here is where we were, né? Yes. Now we see that, oh, okay, I'll just talk. We're given that expression, x approaching 4. But when x approaches 4 from the left, we got positive infinity.
Yes.
When we evaluate the limit when x approaches 4 from the right, we got negative infinity. Is positive infinity equals to negative infinity?
No.
Therefore, how do we conclude?
The limit does not exist.
The limit doesn't exist. Thank you.
Okay.
Can we continue?
Yes, we can, sir. Thank you so much.
Thank you. Before I continue, let me ask, anyone with any challenge on this? Anyone? Oh, that means we are.
Sam.
Hello.
Sbusiso, Sam.
Yes, Busiso.
So can you explain how we got negative infinity as we approach from the right? So.
Okay, brother. It is not a good way of actually explaining it. Ne? The reason being, I'm now using numbers.
Okay,
but in simple terms, that's how it goes. As I usually tell you, as I usually say, I like to explain in simple terms. And then, so you said, why did we get negative infinity? Ne?
Yes, sir.
When x approaches 4 from the right. All right. In simple terms, this is how my story goes. Please, we are now evaluating the limit of x minus 3 over 4 minus x. Open and close bracket. Inside that bracket, we have got x plus 3. As x approaches 4 from the right. Okay. Busiso.
Yes, sir, I'm listening.
All right. Give me any number.
On the right side of 4.
Any number that is to the right hand side of 4.
Okay, say it's 5, sir.
5. Thank you. Now, you and I, let's work on that number that you have given me, and I appreciate that number. And then the next thing that we need to do is to write this limit in 2 parts. Okay, that means we'll have the lim of x minus 3 over 4 minus x as x approaches 4 from the right. Okay, and the lim of 1 over x plus 3 as x approaches 4 from the right. But the number that you have given us is 5. Let's start with the first one. When we put 5 in the place of x in the numerator, we will have 5 minus 3. You agree?
Yes, sir.
Then we'll have 2 in the numerator. Okay?
Yes, sir.
What will we have then in the denominator when we put 5 in the place of x?
Negative 8, sir.
Oh, never.
Denominator, say when we place 5
in the place of x in the
numerator, we get 2, sir.
That means it's 4 minus into minus. No. This means this is 4 minus 5. I'm talking about the lim of x minus 3 all over 4 minus x. I'm still on this one.
Yes, sir.
Remember, you write it in 2 parts. In the numerator, we will have 2. In the denominator, we will have 4 minus 5, which is what? Minus 1. Do we agree?
Minus 8.
Yes.
Sir.
Minus 8, sir.
Minus 8.
Yes, you're going to have 2 over negative 8.
No, guys, I think there's a bit of a misunderstanding here.
Yeah, we are separate.
So I think where Menier is saying x
function.
People, my apology. I thought you understood this concept. Someone send this.
I understand.
Someone send this up. Please talk.
Vuyo's hand is up, Glenn.
Yes, Vuyo. Thank you, Colin. Vuyo, please talk.
Yes, sir. I have this question here. I know limit when x approaches 4 from the left, it's infinity, right?
Positive infinity.
Yes, it's positive infinity, but when we multiply, when we substitute all those numbers that are less than 4, we get a number, a certain number. Why do we conclude that it's infinity? Yes, why do we conclude that it's infinity instead of the number?
Okay.
Can I have a shot at it, sir?
Yes, please go ahead.
Okay. So you're asking about when we are approaching 4 coming from the left-hand side, correct?
Yes, sir.
Okay. So if we take any number that is less than 4, let's say, for example, we take 3, we'll get a certain number. And then if we continue going down that route, if we continue maybe taking 2 and 1 and going down further away from 4, we realize that the product between the two equations that we are multiplying keeps getting higher, and it's positive. So therefore, it will it keeps going lower. So the closer we come to 4, that number will go up. But we know that as per the terms or as per the laws of limits, we can only measure as we are approaching 4, but we're not going to measure when we so when we're drawing the graph is not going to touch 4. It's going to come as close to 4 as possible, but at the time when it's approaching 4, it will just continue going up towards the positive side without the end, which is in this case logically the infinity. So if we take 3 again, if we substitute 3 into both equations, they give us a certain number. And then if we take 3,5, for example, and we substitute it into the equation, the product of these two equations that we are the two equations that we are multiplying that give us a positive the positive number is going to be greater than the one for 3. So if we take 3.7, the closer we come to 4, the higher that number becomes. So we then conclude that it's going to go all the way through to infinity as long as we have not yet gotten to 4.
All right, thank you, sir. I understand. Thank you very much.
Thank you, brother. Now, where were we? We were on, someone asked about the negative infinity. That's where we were.
I say we can continue. I understand now.
Oh, okay. Thank you. If that is the case, then let's come to this part. May I, using the very same technique, may I please request you to evaluate the limit of into x plus 3 all over 4 minus x, open bracket x minus 3, as x approaches 3. Is my question clear?
So we are not approaching from the right nor left, just approaching 3.
We are evaluating this limit when x is approaching 3. Yes, that is my question. This one, exercise 1.3.10. Marvin?
Yes, sir.
Please go ahead.
I got negative infinity, sir.
Negative infinity?
I think so.
Okay. Spusiso, what did you get?
I also got negative infinity, sir, but I think it's positive infinity, but negative infinity, sir.
Negative infinity. Vuyo, what did you get?
Sir?
Hello?
Yes, sir. Limit of x when approaches 3, I get 6.
Positive 6?
Yes, positive 6.
That's Vuyo, ne?
It's Vuyo.
Thank you, brother. Now, let's go to the beginning. Marvin, please explain to us how you got to minus infinity.
The expression I started with the same step that we did in the previous question, that the evaluating at first glance, we see that the expression itself gives us an undefined. Therefore, we have to approach it from both ends, and then I split. First, I did approaching from the left, of which I chose which one did I choose? I chose 2, and from 2 I got the product of the 2. The product of the 2 is a negative value. So because of that, I concluded that it's going to be negative infinity when approaching from -3. And then when approaching from +3, when I first tried to use 4, when I first tried to use 4, I got 7/0. And then I tried using 5, which gave me the product of the two gave me a negative fraction as well. So because of that, I also concluded that it's a negative infinity. And if the two limits are the same, then we can conclude that that's the limit of the expression. But I'm not too sure of what I'm saying at this point.
Thank you for the explanation, Marvin. Thank you. Now, Sbusiso, the stage is yours.
Sir?
Yes.
Oh, it's my turn, sir.
Yes, please.
Yes, please. Okay, sir. Sir, I've reached to the conclusion that the limit doesn't exist because when I place numbers, firstly, when I solve the equation by itself, the limit when x approaches 3, I found that it's hard to find the answer because I get 6 times positive infinity. So I went ahead and tried to approach the limit from the left. And as I approach the limit from the left, what I get is that I get negative infinity. When I approach the limit from the right, I get positive infinity. So my conclusion is that the limit doesn't exist because the limit from the left and the limit from the right, which is negative infinity and positive infinity, are not equal. So the limit doesn't exist. So.
Oh, okay. Now you changed tune from negative infinity. Let me write it down.
Yes.
Write it down. Okay. Vuyo, you got +6, my brother. How did you get that, Vuyo?
Yes, because it's this case here where limit x approaches 3 from the either side, then it's 6. I substituted this 3 because in the denominator we are not getting 0. I substituted 3 as x, then I got 6.
Someone's hand is up. I can only see Wenkosi.
Thando Lenkosi map.
Please
and I
go
think
ahead.
Thando just joined.
Yes, I
Okay.
just joined. I'm sorry I came late. Yeah, so but I'm happy that the question that you are doing is this one, exercise 1.3.10.
Yes.
Okay, I got 0.
You got 0.
Yes.
Please explain to us how you got the 0.
I just substituted where there is x, I put 3. So 3 plus 3 plus 6, then divided by 4 minus 3, which is 1, times x minus 3, which is 0. So I said 6 divided by 0. So I said 0.
My sister, you are worrying me. In the numerator, we have got, from what you said, you have got +6, huh?
No, I said 4 minus 3, which is 1.
Oh, is 1 in the numerator.
Then times, yes, then times the other bracket, I said 3 minus 3, which is 0. So I multiplied 1 times 0, which is 0. Then on top, our numerator is 6. So 6 divided by 0, I said equals 0. So I'm not so sure because I came late. I don't know when we are dividing by 0. Is it infinite or what? Or you just write 0? I'm not so sure. That's what I want to learn. If it's 0 divided by 6, what are we supposed to write? If it's 6 divided by 0, what are you supposed to write? So I just wrote 6 divided by 0, which is equal to 0.
Okay, I hear you. Let's just remind each other that any number divided by 0 is undefined.
Okay.
But 0 divided by any number is 0.
Okay.
Glenn, sorry, before you leave, Norma Homet wrote the question on the chat. Do you have access to the chat to read, to check his question?
Please read it for us.
I broke down the equation into 2 parts. X is Glenn, it's math.
Yeah, he broke it. He broke the question, the expression into 2 parts. Yes, we
Yes.
agree. That is what should be done. Yes. And then
X divide.
X divided by in bracket are 4 minus X close bracket and open another bracket is X plus 3 close bracket is equals to plus infinity. Mara, he broke it into 2. The other one is minus 3 divided by open bracket 4 minus X close bracket open bracket X plus 3 is equals to minus infinity. Half are the final answer. I just use the signs, therefore giving a final answer of minus infinity. I want to know if the above is correct.
okay. Before I can say to you, it is correct or not. I said in my vocabulary, I don't have the word correct or wrong. I don't have those words. Okay.
Sir,
Yes.
I think I kind of made a mistake.
Is it Vuyo?
It's Vuyo. It's Vuyo. It's Vuyo.
Okay.
I revisited the question and did it again. It's not 6. It's the limit does not exist.
The limit doesn't exist.
Yes, sir.
Sorry, sir. I think I would also like to change my answer to the limit does not exist. Not because I can prove it with a simple formula, but I kind of like just took random numbers that are close to 3. No, sorry.
People.
Sorry.
Now you are confusing me. Okay, now I'm now more what? When Kosi's hand is still up, I'm now more worried than I was worried before. Now let's do it slowly together. Let me write it down. Is the limit of x plus 3 over 4 minus x. As x approaches 3 from I will start with from the left. I'm breaking it down as the way Norma Homer did it. Then I'll have the lim of x plus 3 over x minus 3 as x approaches 3 from the left. Because the reason I'm doing this is because I noticed that when by observation, as I said, from the previous exercise, when we put 3 in there, we realize that this expression becomes undefined. Do we agree? Yes or no?
Yes, sir.
Yes, we agree. It's defined.
Like when Kosi did. So now, once we realize that now we know that we need to evaluate this limit when x approaches 3 from the left, and then even when x approaches 3 from the right. So now, let me do it with you the way I did the previous one. Now, when x approaches 3 from the left, Okay, I see 3 on the number line. Now, I'm going to the left-hand side of 3. Let me choose which number. Let me choose -4. Sibusiso, Marvin. Sibusiso.
Yes, sir. Yes, sir.
Okay. As I said, it's not a good way of doing it, but I'm finding it easier in this way. I'm choosing what? I said I'm choosing -5, ne? Sibusiso.
Yes. Yes, sir. You're choosing -5.
I'm choosing -5. What will I have in the numerator? I broke it down into 2 parts, x plus 3 over 4 minus x. In the numerator, I'll have -5 plus 3, which will give me -2. Do we agree?
-2.
In the denominator, it will be 4 minus into -5. So this this number will be what?
9.
Will be 9, positive 9. Eh? So my interest is that this number will just be positive. Do we agree?
Yes, sir.
Thank you. Now we are going to the limit of x plus 3 over x minus 3 as x approaches 3 from the left. Still using the very same number, which I said is -5. When we put -5 in the place of x in the numerator, we get -2. And then below, we will then have -8. Do we agree?
Yes, sir.
Then now we are having this situation where the first number is a positive, the next number is a negative. So now, positive times negative, this is giving us a negative. Do we agree?
Yes, sir.
So do we agree that when x approaches 3 from the left, then we get negative infinity?
Agreed.
Agreed.
Agree.
Okay, as long as we agree, now let's move to the next part. I'm writing it down, is the lim of x plus 3 over 4 minus x as x approaches 3 from the right, and the lim of x plus 3 over x minus 3 as x approaches 3 from the right. Any number to the right hand side of 3. Can anyone give me any number to the right hand side of 3?
Let's check.
4.
4. Okay. Now we are starting with the.
Sorry, sir. Can I just ask real quick?
Yes, Marvin.
Would we then not logically rule out 4 because we see that there is a 4 minus x as a denominator, and knowing that the denominator cannot be 0, do we get mathematically forced to rule out 4, or what do we do in this case?
In this case, I agree with you, my brother. 3 and 4, those are the numbers that will not deal with in this case, because from the beginning, by observation, we realize that those two numbers, any one of them, makes this expression to be undefined. Have I answered you?
Yeah. That's why I choose 4. I wanted your explanation here because I saw that there is 4 minus x.
Marvin. Okay, talk level.
Yes, but you explain it. You explain it like I understand now.
Marvin. Oh, thank you, Lebo. Marvin.
I'm here, sir.
Did you get my explanation, and is it making sense?
Yes.
Thank you. Now, Lebo, you said you are clear. Give us any number to the far right of 3. Lebo.
5.
5. Lebo, please stay on the line. We are starting with the limit of x plus 3 over 4.
Sorry,
Over
sir?
4 minus. Please help me out here. Ne?
Yes, sir.
You gave me that positive number, which is 5.
Yes.
Now, remember when we solve these limits, we had to break down this limit into 2 parts.
Yes, sir.
The first one is the lim of x plus 3 over 4 minus x as x approaches 3 from the right. Another one is the lim of x plus 3 over x minus 3 as x approaches 3 from the right. Now we are starting with the first part of x plus 3 over 4 minus x. You said x is 5. Then when we put 5 in the place of x in the numerator, we have got positive 8. Ne? Do we agree? Level.
Yes, sir.
We've got positive 8.
When we put 5 into x plus 3 over 4 minus x. You said
Yes, that's where I am. What do we
yes,
get? This is the final answer.
Negative 8.
This is going to be negative 8. Thank
Yes.
you. And then when we put that positive 5 into x plus 3 over x minus 3, what do we get?
Sorry, sir.
Why are we before I'm sorry for that. Why are we saying Menier x plus 3 over x minus 3? Because we use x plus 3 divided by 4 minus x.
It's 1. Sorry.
It's 1.
Sorry.
It's
I'm sorry.
It's 1.
I'm sorry.
You're forgiven, sir.
I'm sorry. It's 1 over x minus 3. Yes.
Yeah.
Talking.
Then what we get, Level?
1 over 2. Sir.
Of course.
Positive 1 over 2. Ne?
Yes, sir.
Now we are interested in the signs of these two numbers. The first one is minus 8, another one is positive 2, positive half. Okay.
Which means we are going to get
minus times positive, what is it giving us?
minus.
So now, taking into our observation from the beginning, when we use either 3 or 4, we get this expression to be undefined. So this is giving us negative infinity. Do we agree?
Yes.
Yes.
Negative infinity. Do we agree?
Yes.
Yes.
Therefore, now, the limit of this function when x approaches 3 from the line, the limit of this expression when x approaches 3 from the left is negative infinity. And the limit of this expression when x approaches 3 from the right is also negative infinity. Therefore, we conclude that what will be our answer when we conclude, which Marvin did get?
Yeah, so I had said the answer is the limit is negative infinity. But can I throw the spanner in the works for a second here?
Oh, okay.
Don't, Marvin, don't.
No, please. This is very important for me because
Okay, it's fine. I'm just kidding.
the whole intention of limits is to try and observe the behavior of the variable as it approaches that particular value, right? In this case, it's 3. So
yes,
obviously 5 and 5 in going the other direction gives us the negative infinity, which is in this case a favorable answer. But I chose to be a bit funny, and instead of 4, I chose 3.5. And when you evaluate that, you get positive 26. And then when you evaluate when you choose 3.1, you get positive, I think it was 50 something, or 56 or 42, I think, if I'm not mistaken, somewhere around there. So I realized that between 3 and 4, when you approach 3 from 4 and you take the numbers that are between these two, the fractions, they're actually giving you a rising positive direction, which in this case would give us a positive infinity. Doesn't that then count, or should we not first do 6? Should we not evaluate 6? And if the value of this thing of substituting 6 is less than the value of substituting 5, then we conclude that these values are gradually rising towards the positive direction. I'm sorry if I'm confusing people, but and we can take this offline if we have to, but this is kind of throwing me off a bit, because 3.5 is a value that is between that is approaching 3 from the right as well. Correct?
I agree. But now, from the observation, Marvin, that 3.5 is between 3 and 4, eh?
Yes.
Marvin?
Yes.
So you and I will try as hard as we can to avoid any number that is between the two numbers. We avoid 4. We avoid 3. Now you brought in 3.5, which is between the two.
We are avoiding because they give us undefined.
Yes.
Okay.
Now I see where that wax and the spanner are fitting in now.
Okay. All right. Like I said, I might be funny in this case. I might really be losing my nuts here, but I just kind of like wanted to make sure that I'm not completely lost with the logic.
Yeah. Ideally, even as I said, this idea of using numbers, for me, it simplifies my life. Even though it might be confusing to others, taking into account that even twins don't think alike. In a sense that the number that I choose, someone can choose a different number from me. But the whole idea is that our focus shouldn't be on numbers. Our focus should be on the signs for those numbers. That's where you and I will agree. I don't know whether you get me.
Following.
Are we together on that one?
Yeah.
Whichever number that you choose, well, far to the far left, far down, far down, or to the far down on the right-hand side. Whatever number that you will get, our signs for those numbers will be identical. Someone's Vince, your hand is up. Please talk to us.
Hi, sir. Can you
Hello.
please explain again why are we avoiding 4 if we're coming from the right, approaching 3?
Why we are avoiding
4?
4
If we're
when we
coming from the
approach
right.
3?
Yes,
coming from the right.
Yes.
Okay, by observation, we realize that if we put 3, this expression will be undefined because it will be 3 minus 3. The denominator will 0 multiplied by that other number for whatever. That number that will get there. It will be 0. Do we agree?
Yes.
And then we'll have a number in the numerator and a 0 in the denominator. That is the situation that we don't want.
Oh, okay. Okay, noted. Thanks.
Thank you. Is everybody clear? All right. A few weeks back, we dealt with an expression almost similar to this. Do you still remember? Yes, no?
Yes, sir.
Okay. Please. And I even remember I made a mistake. That person is not here. That person is not, I can't remember who's that person, but if I see the name, I'll be able to remember. I made a mistake and then that person did correct me to say, this is not how we are doing things. I was doing it the other way around. Now, let me request you, with everybody having said that they understand, please evaluate the limit of 9/4 plus h minus 9/4 all over h.
So we don't use first principle, right?
Sorry?
We don't use first principle, right?
First principle.
Yes.
Who's talking?
Lebohang.
Lebohang, please explain the first principle to me.
I'm so because we are in a limit. I'm so I was thinking about the differentiation. So
Okay. Where should I start? Spusiso, what did you get, my brother?
I got -9/16, sir.
Sorry?
-9/16.
-9/16. Tando, what did you get?
I got undefined, then I got 9/4.
You got what?
9/4.
Tando, please talk to me. You said, first you said undefined, and then you said 9/4. Please don't confuse me. Give me one answer, the answer that you have. What is your answer?
9/4.
9/4. Thank you. Level.
Yes.
Level.
yes, sir.
What's your answer?
I got positive infinity, sir.
Positive infinity.
Yes.
Yeah.
That's Bianca. I also got positive infinity because I got infinity.
Bianca got positive infinity. Who else has got an answer?
Yes, sir, I did.
Positive. Oh.
Is it Vuyo? Vuyo?
Yes, sir.
Yes, Vuyo, what did you get?
I get -9/16.
-9/16. There
Yes,
is
sir.
someone behind you. Who's that? Someone who was trying to speak while Vuyo was speaking?
So I got positive infinity.
Is it Noma Ahmed?
Yes, sir.
Noma Ahmed, you got positive infinity.
Yes, sir.
Who else has got an answer? Oh, there is someone. Marvin. 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 Marvin.
Yes, sir. Sorry. I was attending to my baby. He was crying. I didn't solve this one. I wrote on the chat that I'll be right back.
Please tell that baby to behave while we are busy with.
He has just decided he's not going to listen to anyone anymore.
No, the baby must help us. We need the help of the baby.
Hey, good rough.
The baby must give us the answers that we want here. Yeah, that genius must help us. I've got 6 answers from 6 people. Out of these 6 people, 2 people got what I'm looking for. And then 4 found what I wasn't looking for. Okay. Noma Ahmed. Noma Ahmed,
Yes, sir.
how did you get positive infinity?
Okay, so okay, I use values of x from values of h from the right of 0, and then I choose any variable, and then I got a negative answer. So can you hear me?
Please, slowly. I need to follow you. Please
Okay,
start
so
again.
I choose yes, so I choose values of h on the right of 0, and then I got a negative answer. Yes, sir. And then I choose, I went to values of h from the left side, and then I got also a negative answer. And then from there, I just deducted that it was a positive infinity. I'm not sure if I'm wrong, if I'm right, sir.
Thank you for the explanation.
Yes, sir.
There is a mistake that you made. Vuyo.
Yes, okay. Yeah.
Vuyo. Oh,
Yes,
no,
sir.
not. Okay, Vuyo, hang on. Bianca. Bianca?
Yes, sir.
Please explain to us how you got positive infinity.
I got positive infinity since h is approaching 0. I substituted my h as 0. I got 0 over 0, and 0 over 0 is positive infinity. Like a ropile fast to get to the answer.
Yeah, you see, that's the problem. That's the problem. That's the problem. Lebo,
Yes, sir.
also explain to me how you got the positive infinity.
Okay, sir. I've started simplifying this equation, our equation. I said open bracket 9 over 4 plus 8 over 9 multiply by 1 over h. And then I get my lowest common factor, which is 4 open bracket 4 plus h. And then I said 9 multiplied by 4 minus 9 open bracket 4 minus h divided by 4 open bracket 4 plus h. And then I multiply by 1, or I multiply all those things by 1 over h. And then I got 36 minus 36 plus h over 36 plus h, and then I multiply by 1 over h. And then I got by minusing 36 minus 36 is 0, and then numerator is h, and then over 36 plus h, multiply by 1 over h. And then after that I cancel h by h, and then I remained with 1 over 36 plus h. And then I started from the left when h approached 0 from the left. I substituted 2, which is I got 1 over 36. From the left is minus 2, and then I got a positive number, which is 1 over 34. And then from the left, from the right, where h approaches 0 from the right, I substituted, I said 1 over 36 plus 2, where h I substituted 2, and then I got a positive number, which is 1 over 38. So meaning when h approaches 0 from the left, I got positive number, and then when h approaches 0 from the right, I got positive number, which is I concluded that is positive infinity.
Thank you, Lebo. Thank you, Lebo, for the explanation and for hurrying you up. Let me thank you for that explanation. Nah?
Yes, sir.
And most your answer is not what I'm looking for.
Oh, okay, sir.
Okay. I have to pay attention to other things, but Sibusiso and Vuyo.
Yes, sir.
Thank you. Vuyo, thank you for the what I was actually looking for. To all those, Tando, Lebu, Bianca, and Norma Ahmed, this is what I was looking for. Okay. We will talk about it tomorrow. And now I have to join another meeting. Is that okay with you?
No worries.
Sorry? Is it okay?
Yes,
We'll
Yes,
talk about
yes, sir.
this
They
is
were
the
using
answer
the
that,
limits. Okay. It's
this is
fine,
the
sir. I will
answer
do
that,
it.
are you sure?
Yeah, I'm very
Okay.
sure.
Okay, please do it. And then tomorrow we'll start by checking the answers. Okay.
Okay, sir.
For Norma Ahmed, Bianca, Lebu, and Tando.
And everyone else, sir.
Sibusiso got it. And everyone else. Hey, yeah, now I'm on a different window. I can't see. Those are the people that I'm referring, I'm mentioning the names are the ones that I'm having them here on paper. Okay, Magwena. Okay. Bianca, Lebohang, Marvin, Magwena, Pumuzo, Noma Ahmed, Sibusiso, Tando Lwenkos, and Vuyo. My request is that we'll double check. We'll verify the answer tomorrow, but that is the answer that I was looking for. So during your spare time, please go through it again. If you are struggling to get that answer, then we'll talk tomorrow. Okay, that's my request to you.
Can you show the answer again, sir? Sorry. Can you show us the answer again?
The answer is minus 9 over 16.
I wanted to see the steps because I see my step there. So I wanted to see where I did wrong.
Oh, okay. Where is that? Where is that? Here.
Okay, thank you, sir. Thank you. Goodbye. Good night.
Okay.
Thank you. Thank you. Thank you.
On that note, let's call it a night. Let me join on the other side. Good night. We'll talk tomorrow.